Good evening to one and all present here. Now I request Ms. Mohana Priya to start our today's program with the invocation of God. Mohana Priya.
Yes, ma'am. Shri Maheshwari Vasadi Nagarishwari Parameswari Kamitartha Mulutchi Brahmamu Kanyaka Parameswari Deva Devi Maheshwari Jagadishwari Bhuvaneshwari Kavavimamuyallaveenala Kanyaka Parameswari Balachandra Giritadarini Bhavya Sundara Rupini Vaishyavamshaya Shobhivardhini Kanyaka Parameswari Shri Maheshwari Vasavi Nagarishwari Parameswari Kamitartha Mulutchi Brahmamu Kanyaka Parameswari Kanyaka Parameswari Kanyaka Parameswari.
Thank you, Mohana Priya. Now I request Ms. B. Kamakshi, Assistant Professor, Department of Computer Science, to introduce our chief guest and welcome the gathering.
Thank you, ma'am. Good evening to everyone. It's my pleasure to extend a cheerful welcome to you all. Your presence makes us very happy. It is my great privilege to introduce our chief guest, today chief guest, Dr. R. Thirumalai Selvi, ma'am, Associate Professor, PG and Research Department of Computer Science, Government Arts College, Nandanam, Chennai. She has graciously accepted our invitation to join us today, FDP. Madam has completed PhD in Computer Science in Madurai, Mother Teresa Women's University. Madam has completed MPhil in Manoன்மணியம் Sundaranaar University. Madam has 28 plus years of work experience. She has published 58 research papers in various journals and international conferences. Madam has published 3 books. Under Madam guidance, 9 members have completed PhD and 13 members have completed MPhil. Currently, Madam is guiding 4 PhD research scholars. Madam has been an editorial board member for various journals. Madam served as resource person for many international conference, workshop, and seminar. Due to time constraint, I have mentioned only few of her achievements. We are really honored to have you as our resource person, ma'am. Thank you, ma'am. Welcome you, ma'am.
Thank you, Kamakshi ma'am. Now I request Dr. T. Thirumalai Selvi ma'am to take over this session.
Yes. Yeah. Thank you, Kamakshi ma'am, for your nice introduction. Yeah, good afternoon, participants, not only participants, my dear friends. Good afternoon to one and all present here. First of all, I would like to thank the management of Sri Kanyaka Parameswari College of Arts and Science for Women for giving me this opportunity to share my views and ideas. And also my thanks goes to Dr. A. Sudha Ramkumar. She is my MPhil scholar, not only scholar, she is my close friend. I know her for the past 20 years. And her team members, Dr. Sudha Ramkumar and her team members, for putting this much effort for the past 5 days for conducting this seminar, the virtual, not a seminar, virtual FDP, international virtual FDP, in a grand, successful manner. Once again, I thank Dr. Sudha Ramkumar, HOD of Computer Science Department. Thank you, Sudha, for giving me this opportunity.
Thank you, ma'am. It is our pleasure.
Okay. Share the screen, Sudha.
Yes, ma'am. Yes, ma'am.
Yeah,
I made you as co-host for me.
Yeah, thank you, ma'am. My screen is visible?
Yes, ma'am, it is visible, ma'am.
Yeah, 1 second. Close the self view. From beginning, yes. I hide myself. Yeah, can you please? My full screen is not actually the side. I have some
Ma'am, it
images
is visible, ma'am.
fully visible, but I am not
yes.
able to see the entire screen in the corner.
Okay,
In the
okay.
corner, I have some name of the persons like Pachemal and Vinci and all. So it will hide my text.
Ma'am, you
Even
can hide the panel, ma'am.
where I have to go.
On top, I think, ma'am. On top, the 3 dots.
Yes,
The
yes.
3 dots, you can hide a
Pin,
talkable
chat,
panel.
stop video, mute the irukku. Mute, stop video, chat pin and the irukku. Is it possible for you to hide it?
It will be shown to you only, ma'am.
I'm not able to see my entire screen because the corner portions are high.
Or else shall I share, ma'am? Can you share your?
1 second, what can I do? Hide non-video participants.
Yes, ma'am.
Okay. Yeah, now it's clear.
Yes,
Yes,
ma'am.
ma'am. Thank you, Sudha. Yeah. Yeah, good afternoon, participants. My topic is breaking down the layers, exploring the elements of ANN, that is artificial neural network. So first, shouldn't we know first what about what is ANN, artificial neural network? So the artificial neural network is a computational system inspired by the structure and function of the biological neural network, which are found in the human brain. And this artificial neural network mimic the way the nerve cells work in the human brain. It is similar to our human brain. Okay. Then it consists of a large number of interconnected processing nodes known as artificial neurons that work together to process and analyze the complex data, recognize the patterns, and learn from the experience. Okay. Then I'll give you one famous definition given by Dr. Robert H. Nielsen. It's a computing system made up of a number of simple, highly interconnected processing elements which process information by their dynamic state response to external input. That is a definition given by Dr. Robert. Sudha, I am audible and my screen is also visible now.
Yes, ma'am, it is.
Okay, I'll proceed. Thank you, ma'am. Yeah. See, nowadays everyone we hear the word, the term AI, ML, deep learning and all. So first in the top layer we have the artificial intelligence. That is a main top. So without these 3 things, it is not at all possible to survive in our computer field or any IT field. Okay. So this artificial intelligence it plays a vital role in our computer science. So this is any technique which mimics the human behavior using computer or digital processor. Under this AI, we have the machine learning, ML. This is the ability to learn from examples or without being programmed. Then in the middle, that is inside the ML, we have a DL. So in between ML and DL, we have this artificial neural network. It's a very wonderful concept. So this ANN is a computational technique or for machine learning inspired by animal brain. That is, it mimics our human brain. Then we have the wonderful concept deep learning, and this is a neural network have multiple layers and which can extract the complex pattern. For for if you have the problems of very complex problem, we can go for a deep learning. Okay, this is the layers that is arranged in AI, ML, ANN, and then we have a deep learning. Then next one is neural network. How can we compare? Already I told that this neural network is similar to our human brain. So how can we compare our neural network with our human brain? See, in our 12th standard school level, we have studied our human brain. Okay, we draw the diagram of brain and all. So here I am comparing both the brain and the artificial neural network. See these 2 diagrams. First, in the biological network, we have a dendrites. Okay, in our artificial neural network, instead of dendrites, we have the inputs, the similar term. Then in our brain, we have a middle part is called as a cell nucleus. But here we have a nodes. Nodes are called as X1, X2 up to Xn. Okay. Then we have a in our brain we have a cell nucleus is nodes. Then we have the synapse in our brain, and here it is called as a weight. And then at last in our brain we have an axon. But here the similar term is called as a output. So in that way we compare our biological network with the artificial neural network. This diagram represents. We will see briefly one by one. Yeah. Next one. I told how do they mimic the how do they mimic the brain, the neural network. So we all know that in our body, which organ in our body is have the thinking power. It's of course a brain only. So you know how the brain works. So ANN is in its most basic form have 3 layers. That is from the 3, that is the information can be passed from one layer to another layer, and it does like our brain. Our brain will pass our information from one cell to another cell. Likewise here also, from one layer to another layer, the information can be passed. Actually we have 3 layers. One is the input layer, hidden layer, and then output layer. Okay, input layer is nothing but it accepts the inputs in several different formats provided by the programmer. Okay, then the middle we have the hidden layer. Hidden layer is in between the input layer and also the output layer, and the hidden layer performs all the calculations to find the hidden patterns, hidden futures, and also the patterns also. That is the job of the hidden layer. Then finally we have the output layer. That output layer goes through the series of transformations using the hidden layer, and then it finally give the results. That's the output conveyed using this layer. These are all the main 3 layers in artificial neural network. Okay, so in this diagram, orange represents input and the green 3 hidden layers we have. Okay, there is a hidden layer, and finally the red represents the output layer. Here I want to say one. I want to give one tips for that. See, in artificial neural network, the hidden layers are recorded. Whether you can ask me a question, my dear friends, you can ask me the question whether hidden layer is necessary or not. See, if you don't have the hidden layer, means it's a single layer network only. Simply we have the input layer and we have the output layer. Okay, but you can ask me that whether the hidden layer is must or is it need, whether we need it or not. See, when we have the data type as if it is a linear, means no need of hidden layers. Simply we can proceed with the single layer neural network. But if we have a non-linear means we all know that linear means it is like a straight line equation. Okay, y is equal to mx plus c, there is a straight line equation. But my data set, my problem, it contains a non-linear. Non-linear means it may be a curve or it's a convex problem. So if my data set or my problem is a non-linear, then definitely I need a hidden layer. That is a point I want to say, important thing. So hidden layers are required if and only if the data must be separated non-linear. It's not a straight line. Okay. Then what are the components of basic artificial network? That's a very important thing. So components means actually here I'm going to discuss about the 5 components. One is the input. Input already I told input layer, hidden layer, output layer. Input means the set of values which we need to predict. The input only predict the output. Okay. It can be the input may be any futures or attributes in a data set. Then we have the weight also. See here, my dear friends, I want to say in the artificial neural network, 3 components plays a vital role. Without these 3 things, it is not at all possible to predict the output. Okay, so the 3 important components are weight, bias, and activation function. I'll give a brief introduction about these 3. Weight, bias, and activation function are very, very important. Okay, so weight means weights are the real values that are associated with each future, which tells the importance of the future in predicting the final value. Okay, so weight will give the strength of the input. That in that way also I can convey you. Then the next one is bias. Bias is used for shifting the activation function. I will tell you what is activation function and all. Briefly, we will see. So it will shift the activation function towards the left or right, and it can be referred as a y-intercept. Y-intercept means nothing but the line touches the y-axis. So in that case, the value of x is 0. Suppose I want to give the y value as 3, means the y-intercept is x is 0, 3. That is the y-intercept in a line equation. So the bias will shift the activation function towards left or right. And then next one is a summation function. So summation function means I am multiplying the input and also the weight. Okay, and then find the sum. And finally, the activation function, it is used to introduce a non-linearity. See, linear model means it is a straight line only. Suppose I want to have the complex problem. My problem is like my data set contains some curve, some images and all. The curve means then I have to introduce a non-linearity concept. For that, definitely I have to use the activation function. We have several types of activation function. We will see one by one in my future slides. ReLU, sigmoid, tanh, and softmax also. See this diagram, I will explain. Here I am giving the input x1, x2, xn, n number of inputs I am having, and then w1, w2, wn are the n number of weights. So after multiplying the input and weight, x1, w1, x2, w2, x3, w3, so I am getting the summation function sigma. Sigma is varies from I is equal to 1 to n, xi, wi, okay, multiplied by input and also weight. Then I am adding the bias term. I will tell you later why, what is the need of bias. Without adding bias, what happened? Everything I'll explain. So I am adding the bias term. After that, this summation will be forwarded to activation function. F is the activation function. And finally, I will predict the output. Y is my output. So this is the 5 components we need. And the weight, bias, and activation functions are very, very important. Okay. Then, so that's why I gave more number of slides for weight and bias. Okay, these 3 things plays a vital role in artificial neural network. So weight are the coefficient of the equation we are trying to solve. Definitely negative weights reduce the value of the output. Weight means it's a random value between 0 and 1. Okay, so negative weight reduces the value of the output. And then I already told you know the calculation, how the summation of the input. Y is equal to sigma multiplied by weight and the input can be multiplied, and I add the bias term. Okay, x1, x2, xn are the input and weight are the w1 to wn. Then I use the formula x1, w1, x2, w2 like that, xn, wn. Then I have to add the bias. There's a constant term added to the weighted sum. So x1, w1, x2, w2 plus bias. And then this computed value is fed into the activation function. So activation function of x1, w1, x2, w2 plus bias. Okay, that is the calculation behind the neural network. Okay. So input into weight plus bias, it forwarded to activation function. That's the diagram represents. Then next one. Yeah, let us understand one example of what is bias. Simply I'm saying bias. What do you mean by that bias? I'm giving one example. Suppose I want to predict the price of the car in rupees. Okay. So my understanding is the price of the car is dependent on the year it was made, which year it was made, and the number of kilometers it has traveled or it has driven. Okay, so let us assume my hypothesis that the higher the year of the car is more the price, and then suppose the more the car is driven means definitely the price is also cheaper the car. So here here how the weights are reflecting. See, the weights are essentially reflecting how important an input is. Okay, so there is a positive relationship between the price of the car and the year it was made, and the negative relationship between the price of the car and the kilometers it has been driven. So the year and the price is positive, and the number of kilometers it has driven and the car is a negative relationship. Okay, so we expect to see a positive weight of the for the future input future that represents a year, and the negative weight for the future that represents a miles. Okay, so suppose if I am taking W1 is a positive and W2 is expected to be negative. And I will give you one more example. See, I told that that is for weight and all. Weight is very, very important. We have to weight will strengthen the input only. So how to assign the value of weight? I told that 0 to 1 is the value of the weight is between 0 to 1. So how can I assign the weight? Which weight is important or which is the less, which one is less and which one is high and all. I will give you one more example. Suppose I want to attend one function in the outside. Okay, I want to go in the evening. So my input, the features are whether I have to wear a silk saree or normal saree, or I go with my own car, own vehicle transport, car, or whether I have to use my public transport. And then I will see the climatic condition, whether it is a rainy or it's too hot and all. And then whether I go along with my husband and son or myself alone, I have to go. I wear jewels and all. These are all additional, etc., etc. These are all my input features. So based on the input features, how can I assign the weight? So for which one I have to give the higher value of the weight? Friends, I thought that you know the problem, understand the problem. See, the first important, the higher value of the weight is my weather condition only. So if I have the heavy rain, means definitely I won't go and attend the function. Okay, so I'm giving the more weightage for the input feature called as a climatic weather report. Okay, after that only whether it is a public transport or my car or sari and everything and all. So in that way only you have to assign the weights. Okay, assign the weights whether it's a higher one or lower one. Okay, so I think now it's clear for how to assign the value of the weights and what's the role of weights in artificial neural network. Then bias. Next we go for the term bias. Bias is a constant value or vector. It's added to the product of input. Input multiplied by weight plus bias. Okay, to offset the result. And I already told it will shift the activation function either left or right. That is positive or negative side. Suppose I want my model to return the value of 2. In that case, what can I do? So I make the bias as 2. Okay, so return 2 means, suppose I'm getting the input 0. Input 0 means my summation value is 0. While I am multiplying the input value with weight, I'm getting 0. My sigma is 0. So in that case, I want my model to return 2. The value 2 means I will add the bias value as 2. So we can make sure that the neuron of the network returns 2, since even the sum, the product of weight and input is going to be 0. I can add the bias value by 2. And one more question I ask my friend, suppose if we do not include the bias in neural network, what happens? Whether you can ask me that whether bias is compulsory or optional one. I can say that bias is an optional one. No need to add bias. But some cases, if my sigma value, my summation will lead to 0. In that case, we have to add the bias value and make it a non-zero. Okay, that's why we are adding the bias. By suppose without bias, what happens? Simply it will perform the matrix multiplication, that is a multiplied by input and also the weight. There is no use at all. So if you are passing the 0 value or a simple matrix multiplication to other layers, means what happen? Nothing will happen. We won't get the accurate result. So that's why we need a bias. And moreover, it will lead to overfitting of the data set. You know what is overfitting? Overfitting is nothing but my test data, my data set will give a better result in training and worse result for testing. That is called the overfitting. So bias is an important one. And then moreover, this bias also reduces the variance. Variance is nothing but that is a error. And it introduces the flexibility and better generalization to the neural network. Okay, that is a concept behind the bias. Then we can ask so many questions regarding this bias. Whether bias is a single neuron, my input neuron passes the features, that is a x1 from the data set, while the bias neuron mimics the additional feature x0, which is always equal to 1. And then every neuron has 3 properties. One is the bias, second one is a weight, and third one is the activation function. Okay, so the bias weight in each neuron is set to, sometimes the default value is 0 and it is not a small random value, or if you pass the bias value input to the next layer, means it can have the value of 1 only. Okay, then how does my ANN learn? Actually, in the artificial neural network means learning or training is very, very important. Okay, so how my ANN learn? We know that the ANN are trained using a training set. We have a data set. We divide the data set into training part and testing part. We all know that it is 80% training or 20% testing or 70-30. Likewise, we divide the data set into training and testing. Suppose my neural network are trained using the training set. I'll give one example. Suppose I want to teach my ANN to recognize the image, whether it is a cat or not. Okay, so here see the picture. We have a men, women, both children, a boy or girl, and also one cat also there is an input image. So I'm asking, where is cat in this picture? So this is the input I'm giving to the model, that is my machine. Okay, my machine will train again and again the images of the cat, and so here the images of cat are in various positions, straight position, different this side and all. So my model will trained and then it will identify whether it is a cat or not. It may be in any kind of position. Okay, so my ANN will classify the images and provided by deciding whether they are cat images or not. So suppose my ANN identifies incorrectly, giving a wrong answer, means Then you have to apply the back propagation algorithm. I hope that you all know about the back propagation. It's a very basic and simple algorithm, and the back propagation algorithm will help you to adjust it has learned during the training. That is, you have to continue the process. Back propagation algorithm that will be continued unless until if you receive the correct output. Okay, so in that way, the back propagation helps you to get the correct result. That is, it will correctly recognize the cat image with minimal possible error rate. So you must think that your error rate will be in the minimum percentage. Okay. For that, the back propagation algorithm is used. Okay, in that way, my ANN learn it, get trained. Yeah, please, participants, mute your audio. Yeah,
So kindly mute, sir.
Thank you. Then we go for the types of artificial network. There are several types of artificial network. Here I am focusing only on three things. One is feed forward and feed backward, and also Bayesian network. Feed forward, from the name itself, I can easily say that it is a unidirection, forward direction only. There is no backward, there is no reverse. Okay, so here the flow of information occurs in a forward direction, and I'm calculating the input with some intermediate function, that is with the help of the hidden layer, and that is used to calculate the output. So, and moreover, in feed forward, I'm using the mathematical gate. That function is called gate function. In between the input current neuron and also the next layer, that is the output neuron. See the diagram. Here I take the input, and we all know that from the second slide itself, the input can be multiplied with the weight, neuron's weight, and then it goes to the bias. Then I am adding the bias value, and then again it forward into, again, yeah, it forward into, I feed the result of the, then it is forward into the activation function, and then finally I take the output and transmit to the next layer of the neurons. Okay, so this is called the feed forward neural network. There is no reverse direction. Then next one is the feedback neural network. Feedback neural network means the name itself we can easily identify there is a reverse direction. So I have the input layer, hidden layer, output layer also, and then here each and every neuron have a reverse direction also, and also self loop also. See the diagram. So in the feedback neural network only, I am using back propagation algorithm. So I can't apply the back propagation algorithm in the feed forward network. Is it clear? I am applying the back propagation in the feedback only. Okay, so this back propagation algorithm is used to minimize the cost function by adjusting the network weight. We can easily adjust the network weight and bias also with the help of the back propagation algorithm. And moreover, the cost function gradient determine the level of adjustment with respect to parameters, like, that is, parameters means here weight, bias, and activation function. So we can easily adjust the functions and minimize the difference. Difference between, error is nothing but here error is difference between the actual output and also the desired output. That is the term error. Okay, so we have a backward direction. There is a feedback or artificial neural network. Then the third kind of network is a Bayesian network. So Bayesian network means here I am giving the probabilistic graphical model, which represents a relationship between the variables and also the probability distribution. Okay, so each node in a Bayesian network represents a random variable. Here I have 4 nodes A, B, C, D, and each and every node is connected by a arc or edges. Okay, and the edges between the node indicate the conditional dependencies between the variables. So I have a random variable is called as a nodes, and the conditional dependency between the variable is called as a edges. I'll give one example for that. The Bayesian network could represent a probabilistic relationship between the disease and symptom. See, suppose I went to the doctor and I'm saying that, sir, I have a cough, cold, running nose, headache, body pain, and all. So my doctor will say, finally, you have a fever. Or suppose suppose I have a continuous fever for the past 7 days, means it may be. It may be, that is a word. You must note that it's a probabilistic. You may have viral fever or typhoid or something else. So based on the symptoms, my model will identify the disease. It may or may not. Okay, so given the symptoms, the network can be used to compute the probabilities of the presence of the various diseases. So A, B, C, D, 4 nodes, and A is the parent of B, and the node B is directly connected to A, and the node C is independent of A. Okay, so the graph does not contain any cycle. So I can say this is a directed acyclic graph or DAG. So this is the concept behind Bayesian network. Bayesian network means it's a probabilistic relationship between the disease and symptoms, may or may not. Okay, then these are all the types of neural network. And next one, how do my ANN works? What is the working principle? Okay, how it works. So it's a weighted directed graph, which artificial neurons are nodes. And we know that edges are also connected, that is weights are also, edges with weights are connection between the output and also the input. See the same diagram only I have already discussed. X1 to Xm are the inputs. Theta 1, theta 2, theta 3 are the weights, n number of weights. And I'm multiplying X1 and theta 1. I'm getting the summation sigma. Then this value is passed to my activation function. That is a non-linearity activation function. And finally, I will get the output. My output is called as a y cap. So y cap is this is a mathematical expression I'm giving. Output y cap is my output, and G is a non-linear activation function. And I already told that why we are using activation function to implement the non-linear concept. Definitely, I need an activation function. Otherwise, I won't get the better result. If it is if my problem is a non-linear one, then theta naught is a bias. I varies from 1 to m multiplied by the input and also the weights. That's a linear combination of input. So that is a basic calculation done in the artificial neural network. Okay. Then next one. Yeah, the same concept, but here one important point I want to say. That is each input is multiplied with the weight, okay, which represents the strength weight represents the strength of the input input connections and all the weights are weight and input are summed up, and then it will give the value, summation value. Suppose I already told that what is the need of adding bias. Suppose my sum is 0, my sigma is net input function is 0. In that case, what can I do? So that one, in that place only, I add the bias value to make the summation to non-zero or to scale up the system response. Okay, that's why I need a bias. And one more thing, here I have in the see the diagram, I have a threshold function. Okay, that is the activation function. Inside I set one threshold. So what is the meaning of the threshold mean? Suppose I'm getting the sum value after adding bias, some value I will get. That value range may be 0 to infinitive. So how can I predict the value with which contain a 0 to infinitive? So I want to do some limitations in the value. So to limit the response to arrive at the desired value, I have to set the threshold value. Usually the threshold value will be some 50% and all. Okay, so after setting the threshold value, the sum is forwarded to the activation function. Suppose my activation function value is greater than the threshold value. Suppose my threshold value is 50%. My activation function, the value which I received after summation is suppose 60%, means that time the neuron will be activated or fired or triggered. Otherwise, I deactivate. Okay, I won't pass to the next layers. If the value is less than the threshold value, I won't pass the value to the next hidden layers. Okay, that is the concept behind the threshold value and then the activation function. I set one threshold value. Okay, so that if it is greater than, then only my neuron will be activated. So to limit the range 0 to infinity, I use the threshold value. So this is a diagram. See the diagram, net input neuron summation, and then it passes to the threshold function, and then I predict the output value y cap is my output with the label either 0 or 1. That part is called as a prediction part. Okay. Then next part is the updation part. Why I go for updation part? Suppose if I am not getting the exact correct answer, I am checking, the comparator will check my original class label is y. But my system output, desired output is y cap. So you compare y and y cap. So if there is a difference, it means that's called as a error. See, here I'm giving error. So what happens if some error occurs? That is, I'm not getting the accurate result. I'm getting the error means, then again I come back and adjust the weight and bias. So unless until I adjust the weight and bias repeatedly, so until I get the exact answer. So the second part is called as the updation part. Okay, so in that way my ANN works. Then we go for the activation function. I told that the three important concepts are weight, bias, and then activation function. So this activation function helps the neural network to use the important information only. It will take only, consider only the important information and suppress the irrelevant data points. Okay, that is the role of the activation function. And my activation function decide whether the neuron will be, whether the neuron will be activated or fire or triggered, all the same term only, or not, by calculating the weighted sum and further adding bias to it. Okay, whether the neuron should be activated or not. Then the purpose of my activation function is to introduce the non-linearity of the output of the neuron. That is also an important point. Then one more tip that I want to give, whether we have an input layer, hidden layer, output layer. So whether we can use activation function, same activation function in the hidden layer and also the output layer. It is my question. You may ask, see, my friends, we can't use the same activation function in the hidden layer and also the output layer. For hidden layer, we use some other activation function, and for output layer also we can use some other activation function. The later slides, I will tell you which kind of activation function, where we want to use, where we will use, and what kind of problem we have to choose the activation function and all. Okay, so normally hidden layers use the same activation function. Okay, all the hidden layer. Output only we use some other activation function. Okay, so output layer will use a different activation function from the hidden layers. So how can we choose the activation function? The activation function depends upon the goal or type of the prediction made by my model. Suppose if it is a CNN, convolutional neural network, means everything will be chosen by the model itself. We won't give anything at all. My filter, activation function, everything will be decided by the model itself. That is the beauty behind the convolutional neural network. And then, my model will decide the activation function. That's the goal. And then, moreover, the activation function, it depends on the structure, data set, and purpose of the network. Okay, see the diagram. Here I am giving a linear function. Linear means it's a straight line. And then suppose non-linear means it's like a curve. So compared with the linear, the non-linear, all my data points will be exactly fit into the line. Okay, that's why I'm using the non-linear. For the non-linear problem, my activation function will be very, very useful. So why do we need activation function? What is the purpose? So suppose I have a neural network working without activation function. What happened? So the data would pass through the nodes of the layers, only going through the linear function. Linear function is what? I am multiplying the input with the weight and adding bias. That's all. That's a linear one. Suppose every neuron will only be performing a linear transformation on the input with the help of the weight and bias. So the importance of the activation function lies in making a model to learn and execute a difficult task. Already I told you, no, my problem is a complex one. Means I have to definitely use the activation function. So it doesn't matter that how many hidden layers are there. My dear friends, can you tell me how many hidden layers we can use in the neural network model? We can use any number of hidden layers. But if we increase, sometimes if we increase the hidden layers more and more, that is called as a dense layer or deep neural network. So if I increase hidden layers more and more, means sometimes it leads to complex only. Normally we can use 2 or 3 or 5 hidden layers, and moreover calculation says that the hidden layer will have the 2/3 of your input. Okay, we can use the hidden layers as 2/3 of the input. Okay, so it doesn't matter how many hidden layers we attach in the neural network. And if I am using a linear one without activation function, means all the layers will behave the same way, because when I multiply the two functions, the composition of two linear functions is again a linear only. So I won't get any results at all. That's why I go for a activation function for non-linear purpose. So there are several types of activation function. We have a linear activation function and non-linear activation functions also. It depends upon the problem which you choose. So binary step activation function is one kind of linear activation function. Here the threshold value which decide whether the neuron should be activated or not. Okay, so f of x equal to 0, x value less than 0, 0. And suppose if x value is greater than or equal to 0, it will give 1. So it is compared to the threshold value. I told what is threshold already. Suppose my input is greater than the threshold value, means neuron is activated, else it is deactivated. So deactivated means my that is the output is not passed to the next hidden layers. That is a binary step activation function procedure. Second linear activation function is the name linear activation function. It's known as, there is no activation. We can say the different name called as no activation identity function. Just it doesn't do anything at all. It will split the weighted sum of the input. Simply split the value, output value, which was given. So the equation is f of x equal to x only. It is a straight line. Linear means it's a straight line only. The equation stands y is equal to mx plus c. So these are all the two type of linear activation function. We have variety of non-linear activation functions also. Okay. So the non-linear activation functions solve the limitations. I can overcome the problems in the linear activation functions. So the non-linear activation function allow the back propagation. Linear activation function, I can't apply the back propagation concept. Okay. So in non-linear, I apply the back propagation problem, and it's a derivative function. It will be related to the input, and we can easily go back and understand, and I can easily adjust the weight of the input neuron to provide the better prediction. It will give the better accuracy of my result. And moreover, the nonlinear activation function allows the stacking of multiple layers of neurons to create a deep neural network, dense neural network, which is required to learn the complex data set with high accuracy. So that is another advantage of the nonlinear activation function. That's why most of the people, those who are doing research and all, use the nonlinear activation functions only. So we have the functions like sigmoid, logistic, tanh, and ReLU also. We will see one by one slowly. Okay. So first one is a sigmoid. It's a nonlinear function. So it can take any real value. Suppose my output will have the range of 0 to 1. So how can I choose the activation function? Suppose I don't know what function I have to choose, whether it's a sigmoid or ReLU or tanh. Don't worry about it. We just see the target value, goal value. We are having so many input attributes, and you also have the target value also. So in the target value, you see the range of values, which range it is between. Either the target value is 0 to 1, 0 and 1, or -1 to 1. So you just see the target value. Based on the target value, you have to choose the activation function. See, suppose my range of target value is 0 to 1. Then you go for sigmoid function. Okay. So the equation of the sigmoid function is f of x equal to 1 by 1 plus e power minus x. Okay. So this function is used for models. We have to predict the probability of as an output, either 1 or may 0. So the probability of anything which exists between the range 0 and 1 means sigmoid is the right choice. Okay. You can go for sigmoid. That is the activation function sigmoid. Then tanh, hyperbolic tangent. See, it is also similar to sigmoid only, but it has a shape that is a shape only, and the difference in output, its range is there, it is 0 to 1, but here it is -1 to 1. Suppose in my problem, I have the target values are listed between -1 to 1 means you choose tanh activation function. Okay, it will give the better result. You can choose some other activation functions also, but you won't get the accurate result. If you want to get the accurate means, see the range of values in the target one, and then choose the corresponding activation function. So for tanh, the equation is e power x minus e power minus x divided by e power x plus e power minus x. Okay. So what is the advantage of this activation function means it is a zero-centered. See the curve is a S-shaped curve. The curve that is 2 quadrants, negative quadrants and also positive quadrants. I have the curve, and also in the middle that is called zero-centered. So it is a positive, negative, and also that is positive, negative, and also neutral also. So if I want to take the values both positive, negative, and 0, go for tanh activation function. Then next one is a very, very important function. Usually people often choose the function, and this activation function mainly we use in the hidden layers only. We don't use it in output layer. Okay, hidden layer only we use the activation function. It's a very important rectified linear unit. Okay, in CNN and all we use the this famous activation function. It is a derivative function only. It also allows the back propagation. Already I told that non-linear activation function means they use the back propagation. Linear equation we can't use. Okay, So the mathematical equation is f of x equal to max of 0, x. Actually, what is the beauty behind the ReLU function means, that's a wonderful, that is the concept behind the ReLU. It does not activate all the neurons at the same time. Whatever neuron I want to activate, that is the result. So it won't activate all the neurons at the same time. So the neurons will be deactivated if the output of the linear transformation is less than 0. Then it will be deactivated. So it won't activate all the neurons at the same time. That is the concept behind the ReLU. And we also have several kind of ReLU functions like leaky ReLU, parametric ReLU, exponential ReLU and all. I don't want to discuss all those things due to time constraint. So this ReLU is a very, very important function. Okay. So it won't activate all the neurons at the same time. It will, if the value is less than means it deactivate it. Then again, the one more important function, that is the softmax. Actually, softmax function is used in the output layer only. Okay, it is a function which returns a vector of k real value into a vector of k real value that sum to 1. So the input values may be positive, negative, 0, or sometimes it is greater than 1. In that case, my softmax activation function transform the value between 0 and 1. My input may be positive, negative, 0, or greater than 1. It may be any kind of input, but my softmax will transform between 0 and 1. So that's why the softmax is called as a probability function. Okay, so any kind of input you can give, it will be transformed between 0 and 1, the value. So if the value is between 0 and 1, the range, so which is very it's a very nice, it's a good one for me, good thing for me, because we are able to avoid the binary classification. Binary classification means either 0 or 1, two things only. Okay, so I can avoid the binary classification and I can accommodate many classes, as many classes of dimension in my model. Okay, that is the beauty behind the softmax function, and that's why the softmax is called as a multinomial logistic regression. Okay, another name. Participants, please mute your mic. Yeah. The mathematical equation, I can represent the mathematical equation as a softmax function as the exponential of zi divided by sigma j exponential of zj. Okay, that is a softmax function equation. Then next one is a swish. It's a new thing. Mostly we don't use a swish function and all. Often we can use ReLU, softmax, tanh only. But see, the ReLU has been the best activation function in deep learning community for a long time. People are using the ReLU only. But the Google's Brain team announced Swish as an alternative to ReLU from the year 2017. So the research by the authors, some research papers shows that simply you can substitute, instead of ReLU units, you can use applied Swish units, means it will improve your classification accuracy by 0.6%. So while when compared with ReLU, if you apply Swiss function, activation function, means it will improve the accuracy by 0.6% in the network like model like ResNet V2. Okay, so it outperforms the ReLU in many deep neural networks. So compared with ReLU, Swiss will give the accuracy more than 0.6%. So the formula is y is equal to x into sigmoid of x, and my derivative is y dash equal to y plus sigmoid of x into 1 minus y. I can say that it's a soft curve and non-monotonic function. What do you mean by non-monotonic function? That is, it's a function which whose first derivative changes the signs. It shows both increasing as well as a decreasing for some time, or in intervals it shows a different behavior at different points. That's why I call this as a non-monotonic. Okay, so being it's a non-monotonic, it enhances the expression of input data and the way to be learned. That is the beauty behind the Swiss function. Then here I'm giving some suggestions for the researchers, those who are doing research in the neural network concept. Okay, so how to choose a right activation function? We have several type of activation function. How to choose right? Actually, we need to match the activation function for our output layer based on the type of prediction problem what we are solving, the type of the predicted variable and variables also. The thumb rule says that we can begin with a RELU activation function. We can start with a RELU and move over to other activation functions. If the RELU doesn't provide the optimum result, go for some other function. So better you choose RELU. If it is not getting, if I'm not getting proper result, choose some other functions. So I'm giving you some few guidelines. That is, RELU function should only use in the hidden layers. Already I told, hidden layers RELU, output layer softmax. Then sigmoid and logistic tanh should not be used in the hidden layers. Why? Because if you use these functions in the hidden layer, means it will the model more susceptible to problems during training, and we will give error. Vanishing gradient means error and all. Okay. Then the switch function is mainly used in neural network. Suppose I have the layers more than 40. My hidden layers are more than 40, my depth. Then you go for switch function. These are all some suggestions for choosing the right activation function. Then some few rules for choosing the activation function for your output layer. That is for hidden layers, and this is for output layers. For prediction problem, how to predict the output. Suppose if it is a regression means, go for linear activation. Binary classification, use sigmoid. Multi-class, more than one class means softmax. Okay, because the classes are mutually exclusive. Multi-labels you have means go for sigmoid, because each label represents a different classification task, but the task are somehow it should be related one. So the activation function in the hidden layer is typically chosen based on the type of the network architecture. So it is based on your network architecture. And then CNN, suppose my type of the network is CNN, convolutional neural network means use RELU. Recurrent neural network means use tanh or sigmoid. These are all some suggestions how to choose the right activation function based on the problems. Then I go for neural network architecture type. See, we are having multiple types of architecture. I am not going to discuss about all the types. Some basic important types only I am going to discuss. That is, we have perceptron model, radial basis, multiple perceptron, recurrent, long-term, short-term, LSTM, Boltzmann, conventional. So we will see one by one, and some important network only, architectures only I will explain briefly. Okay. See, first one is perceptron. Perceptron is nothing but it is a single layer network. Okay, it is a building block of ANN, I can say. So it's a simple one. It have a two input unit and only one output unit. See the diagram, 2 input and only 1 output, and no hidden layers. Perceptron single layer network means there is no hidden layers. Then second one is radial basis function. So here I am using the RBF function. It is a real value function, and the value depends only on the distance between parameters. Parameters are nothing but they are the weight, bias, activation functions only. Okay, so ABC are the parameters of the network. So multiple layers are compressed into a single one. That is the concept behind the recurrent neural network. See again. So here input layer, hidden layer, output layer, X is the input layer, and H is the hidden layer. ABC are the parameters, and the current input is a combination of X of t and X of t minus 1. The output at any given time is fetched back to the network and to improve the output. So in what way my RNN will overcome the problems in single layer network or the multiple layer network? So my forward neural network cannot handle sequential data. It can be overcome by RNN. And moreover, my forward neural network consider only the current input only. Okay. And it cannot memorize the previous input. But RNN will do all those things. Okay. Then next one, another very, very important concept, LSTM, long short-term memory neural network. And it is a type of neural network in which memory cell, the name itself, we know, long short-term memory. So which the memory cell is incorporated inside the hidden layers, into the hidden layers. And it is called, that's why it's called as a LSTM network. It has 3 parts. The first part chooses whether the information coming from the previous timestamp is to be remembered. The previous information is remembered, or suppose if it is irrelevant of my problem means it forgotten. It can be forgotten. That is the first part. Second part is I have to learn the new information. The second part will learn the new information from the input to the cell. Third part is the cell passes the updated information from the current timestamp to the next timestamp. Okay. So see the diagram here. That is the first part is a forget state. Suppose the informations are not necessary, my model, my network will forget. That is a forget the irrelevant informations, forget gate. And I have the second gate called input gate. That is I add or update the new information. Okay, learning. Third gate is the output gate. I pass to the next layer by updated information, pass the updated information. These are the three gates. So here I'm saying, mention three parts of LSTM. Flow of information in and out of the memory cell or LSTM cell. First gate is the forget gate. Second one is the input gate, learning some new things. And third one is the update the information and through the output gate. It consists of the three gates as a memory cell. And it's a traditional feed-forward neural network, and each neuron have a hidden layer and current state also. And then the hidden state is known as a short-term memory. See the diagram? H is the short-term memory, and C is a cell state. Cell state is known as a long-term memory. Okay, see the diagram. Then I'm giving you an example for this LSTM because it's very important concept. That's why I'm giving one example. Bob is a nice person. I have two sentences here. Bob is a nice person. Another sentence after full stop Don on the other hand is evil. I have two sentences. Let us take an example how this LSTM work. See here you have two sentences separated by a full stop. First one is a Bob is a nice person. Second is a Don. On the other hand, it is evil. It's very clear that in the first sentence we are talking about Bob only. Okay, and as soon as we encounter the full stop, if I see my model will see the full stop as soon as it started talking about Don. It forget the Bob. It goes for Don, second sentence. So as we move from the first one to the second sentence, my network should realize that we are no more talking about the first one, Bob. Okay, so now my subject is Don only. So here only the forget gate of the network allows to forget about the first sentence. In that way, my LSTM works. Is a very small example for understanding purpose, and we are using this example. Then other network like half-wheel network. It's a fully interconnected network of neurons in which each neuron is connected to every other neuron, and my network is trained with input patterns by setting the value of neuron to get the desired pattern. Here then weights are computed and weights are not changed. Once trained for one or more patterns, network will converge to the learned patterns. It is different from some other network, half-wheel network. It's a very big concept, just for definition purpose only I'm giving. And moreover, it is associated with the concept of simulating, similar to the human memory through pattern recognition and storage. I can say the traveling salesman problem is also a good example for this half-wheel network. Then another network is Boltzmann machine neural network. This also somewhat similar to half-wheel network. Some neurons here, see the diagram. I have two colors. One is a green and another one is an orange color. Okay, so the green color represents that inputs are there. Some neurons are act as an input and some other neurons are hidden. The green may be the input and the orange may be the hidden one. Okay, I can't see that one, and the weights are initialized randomly and learned through the, here I am using the backpropagation algorithm in Boltzmann machine. And another very, very important concept. I thought that in Kanyaka Parameswari College last month I gave a seminar related to for students related to this convolutional neural network with a demo. That is a practical demo using Anaconda, Jupyter, Python. How my CNN works for both the images and also the digit also. I remember. So my CNN convolutional neural network is a very important neural network, type of neural network. This neural network mainly works for images. It will give very good results for images. For if your data set contains images, means definitely you can go for CNN. Okay. So for image classification or image recognition, the CNN plays a vital role. For face recognition, object detection, and all other applications, we can use CNN. it is similar to forward neural network only, and the weight and bias are also available in neurons. So my CNN takes the input image as an input and it is classified under a certain category, whether my input are cat or dog, lion, tiger, my input images, and the computer sees the image as a pixel. Okay, and this pixel depend on the resolution of the picture. Okay, so based on the image resolution, it will see h into w into d. H means height, w is the width, and d is the dimension. Suppose my image, my data set, image data set is a colored image, is RGB, means size is 6 into 6 into 3. 3 is the 3 channels, red, green, blue channel, array of the matrix. And then suppose if it is a black and white, grayscale image means size may be 4 into 4 into 3 array of the patterns. See the diagram, I'll explain the diagram. Here, each input image will pass through the sequence of convolutional layers. Okay, convolutional plus ReLU. ReLU already I have discussed. Okay, convolutional means here this convolutional layer will extract the features from the input data set. Okay, here all, and one more thing, here in CNN, that is the difference between machine learning. I want to note one point here. The difference between machine learning and deep learning is, in machine learning, feature extraction and classification done separately, but in deep learning, feature extraction and classification done at the parallel, simultaneously we are doing both things. See, the job of the convolutional layer is it extract the features. Future extraction it will do with the help of the filters and all. Okay, it's a very big concept. And then ReLU is used for nonlinear function. Okay, then it go for pooling. Why we need pooling? Pooling means to reduce the dimension of the image, dimensionality reduction. That purpose we are using the pooling. We have max pool, min pool, and all. Okay, so it will go conventional plus ReLU, then pooling, then again conventional plus ReLU. It passes through any number of layers, more number of conventional ReLU and pooling layers, and finally that is a part called future extraction part. Then it go for a classification part. Classification means, then here I have the flattening. What is the need of flattening? Flattening is nothing but here the 2D array. The result may be after future learning. The result will be a 2D. The 2D will be converted into a one-dimensional array. For that purpose, we are using flattening. Then it go for a fully connected layer. Fully connected means that is called as a dense layer or deep neural. So the fully connected layer, what it will do? It map the representation of the input and also the output. Mapping will be done at the fully connected layer. And I told you, no, output layer I'm using softmax function. Hidden layer I'm using ReLU function. So here the output layer I'm using the softmax function, and finally it will do the classification whether it is a car or truck or cycle and all. Okay, so that is the concept behind the convolutional layer network. Here we are using some filters also. In the convolutional part we are using some filters. Or we can say this as a kernel. Okay, then next one, modular neural network. And it is functionality independent, task is divided like models. We can divide the big model into a smaller model for computational purpose. And then the networks are more powerful than the flat and unrestricted. We can say it follows the divide and conquer principle. A big thing can be divided into smaller. And finally, we have the physical neural network. It is also similar to our artificial neural network only. Here, the individual neurons is modeled by actual physical materials rather than the software. I am using the physical materials only. So the electrically adjustable resistance material is used to emulate the synapses instead of the software simulation. Okay, in a neural network. So the important concept like LSTM, CNN, RNN, I have discussed briefly. Okay, then learning techniques. Sudha, shall I proceed? The learning concept. We have time up to 5:15. No. Sudha, are you there?
Yes, ma'am. Yes, ma'am.
Shall I continue the another concept in?
Yes, ma'am. Yes, ma'am.
Okay, fine. Thank you. So this is another very important concept. So far, I told that suppose if I am not getting correct answer, means I have to go back, use back propagation algorithm, adjust the weight, adjust the bias. So that term only I often used in artificial neural network. So here I am going to say how to adjust the weight and bias. Okay, in what way, how to adjust the weight and bias. So for adjusting the weight, the parameters like weight and bias, we have several learning rules. So that only we are going to see. Learning techniques in ANN, it's a very difficult one only. Understanding is somewhat difficult only, but anyhow, it will be useful for research people, how to adjust the weight and bias. So my neural network learned by adjusting the weight and bias iteratively again and again, unless until I achieve the correct result. So these are all called the free parameters. So for learning take place, neural network is first you have to make a training. After that only go for a testing. Okay. The training is performed using a set of rules known as a learning algorithm. So learning algorithm is nothing but I framed some rules for training. That is a learning algorithm. So I have famous algorithm, two algorithm, gradient descent and back propagation. Gradient descent is a very, very simplest learning algorithm. It's a supervised learning. It comes under supervised learning. And here I already told my actual output is differ from the desired output, means then the error is found out. And my gradient descent algorithm, gradient descent means the error only. Okay, changes the weight of the network in such a way to minimize the mistake. Error will be reduced with the help of this algorithm. Back propagation, you know already. It is also some extension of the gradient descent only. It is based on delta learning rule. Here, what I am doing, after finding the error, there should be some error with the original output and also the desired output. Okay. So if I found some error in there, it means then propagation, that is backward. In gradient descent, I am not doing the back propagation, but here I am doing, I come back and adjust the weight. Okay. Propagated backward from the output layer to the input layer, reverse via the hidden layer. Okay. So it is used to the multi-layer neural network. So gradient descent means just I'm finding the error, calculating the error between the original and the desired one and how to minimize the mistake. Back propagation means even if I found the error, they come back and then from the output to the hidden and to the input and then adjust the parameters, then I'm getting the exact result. These are all the very famous two algorithm learning techniques in ANN. Then this concept already we know the data sets, training set, the 80-20 I told you know. So for learning it is fit to the parameters. Parameters means weight, bias and all, and one full training cycle on the training set. Validation means the example is used to tune the parameters, that is the architecture of the network. Suppose to choose a number of hidden units in the neural network, that is a validation approach. Test set means it is used only to assess the performance, that is called generalization of a fully specified network, or you apply successfully to predict the output whose input is known. These are all the data sets, training, testing and validation. These are all the learning rules. That is, it's a method of modifying the weights of connections between the neurons. And these rules enhance the neural network performance by applying this rule over the network. And it will update the weights and bias level of a network with certain conditions are met in the training process. We apply the learning rules in training process only. And I told already it's a very crucial part of the development of the neural network. There are very different types of learning rules. Hebbian, perceptron learning, delta learning, competitive, memory-based, correlation. So I am not going to discuss about all those rules, only 3 learning rules. Here I have taken three learning rules only. We will see one by one if time permits. So before going to these learning rules, we will see what is a basic learning mechanism, what is the objective behind the learning concept. So we can say either learning or training, both are same only. So I'm given with a lot of new training data to make my model to learn more and more. Then only I'll get the I'll get a better result. The next one is a generalization. Generalization means after expose a new data, it generalize the data, that is, it forms a patterns. Okay, you know what is patterns? Finally, my neural network is simulated by the environment. So it experiences changes in these parameters or internal structure as a result of the simulation. And moreover, it responds in a new way to the, that is, my network will adapt to my new way to the environmental stimulus or changes because of these changes which have occurred in its parameters or internal structure. Even if I change the parameters, either it may be a weight or bias, it should be, my network should be adapted to the environment. That is the concept behind the learning mechanism. Okay. So what is learning? The main objective of learning is to make my network to learn or train itself. Okay, it is a process by which a neural network adapt or adjust itself to any stimulus. Okay, stimulus means some outside condition, outside exposure given to it by making proper parametric adjustment in order to generate the desired output. What is my goal in the learning mechanism? I have to produce an accurate result, desired output. That is my goal. Then two kinds of learning we have. One is the parametric learning, another one is the structural learning. Parameter means changing or updating the parameters like weight or bias. Structural learning means it focuses on changing the entire structure or architecture of the network instead of changing the parameters. So the first type of learning is error correction learning, or the another name we can say perceptron learning. Perceptron means single layer network. So this learning comes under supervised learning only. It is a technique of comparing the system output with the desired output, comparing the original output with the my desired output. Okay, and using the error to direct the training. So I'm calculating the error, the difference between the original and also the desired one. This algorithm the goal of the algorithm is to minimize the error signal at each training iterations. The formula is sigma n is equal to of ek squared of n. So I already told the same thing only. E is the error, D is the target output, and Y is my system output. That is the D is the original output, Y is the system output. The difference is called as a error. Okay. So the objective of this learning is minimize the cost function or the index performance of defined in terms of the error signal. We can say this algorithm as back propagation algorithm. Then this is a working principle. Error correction learning. We have the input and output layers of neuron, input signal, comparator. Comparator means which will compare the original one and also the desired one. And it's also another name we can say this is a parameter based learning, because here I am adjusting the parameters, weight and bias. See the diagram, I'm giving the input, multiple layers of hidden layer will pass through, and finally I will get the net input, and then it pass through the output neuron. I am getting the output Y, that is my output, desired output. And then the summation is given into the output neuron. Suppose if there is some error, difference between the original and also the desired means that is called as a error. Okay, I am calculating the error and my goal is to reduce the error. That is the concept behind the error correction learning. See, this is a mathematical, some graphical representation. Vk of n is the input and this is a specific output Yk. Error term Ek of n is equal to dk of n minus y, d minus y I told. Goal is to minimize the cost function delta k. Delta k is equal to half into ek squared of n. That is the formula behind the error correction learning. Okay, so the same thing only, and here delta wk is the change in error. Okay, so change in error is n, or we can say eta, that is a lambda we can say. That is a positive concept. It's a learning rate, I can say. I can use the word learning rate of learning. So what do you mean by rate of learning? It's a hyperparameter which use training of neural network. It has a small positive value, the range between 0 to 1, and the rate, the learning rate, which controls how quickly the model is adapted to the problem. That is a role of the learning rate. And X is the input signal, E is the error one, delta WK is a change in the synaptic weight. So the other name is called as error correction learning. We can say the rule is delta rule or Woodrow-Hoff rule. The another name also, yeah. So don't get confused. It's basic concept I'm telling you. The next very important learning rule is competitive learning. From the name itself, we can say there should be a competition between the neurons. Okay, which one will get the higher value or lower value? Which neuron will be activated or fired? Okay, it is a form of unsupervised learning. Okay, and here the nodes compete for the right to respond to subset of the input data. The another name for learning is winner take all network. So in anywhere, winner only get a choice. Even if it's a classroom or anywhere, only the winner. So winner take all the networks. It chooses the neuron with the greatest total input as a winner. So I'm calculating all the total input, okay, of the total input of the neuron. Which one have the higher input? That will be that neuron will be triggered. Okay. So the connection between the output neuron, see the connections, the output neuron connections, and they have a severe competition between them. One of them would be on, and which means the neuron which will be on will be the winner. Okay, others will be off. They are the loser only. Okay, so by increasing the specialization of each node in the network, the competitive learning will work. So it consists of a single layer of output neurons. And see, all the neurons are, see the black bold diagram. Here, all the neurons are fully connected. Each and every node will be connected. Input neurons are connected. So all the output neurons compete against each other to try to get the fire. I want to fire. I want to activate. Each and everyone have the heavy, severe competition between the nodes. Okay. So the concept behind the competitive neural network is there should be a feedback connection also. See, feedback connection also between the output, and the connection between the outputs are inhibitory type. That means inhibitory means there should be a daughter line. Second diagram, see, between the output there should be a daughter line, which means that the competitor never support themselves. Okay. So there should be a severe competition, and the neuron which have a output neuron which have a higher output on and others are off. That neuron will be declared as a winner. Okay. This is a graphical diagram. I don't want to explain all those things. The rule behind the competitive learning is winner take all, because only the winning neuron is updated. No need to update all the neurons here. Whichever the neuron have a high value, that is the value 1, it will be updated, and the rest of the neurons are left unchanged. Keep it as same. That's the concept behind the competitive learning, and only one learning, finish it off. Yeah, Boltzmann learning, it follows a stochastic learning algorithm. Okay, stochastic learning algorithm. It's similar to somewhat error correction learning. So here, instead of direct difference between the result value and the desired value, here I am calculating, or I can take the difference between the probability distribution. That word is very important. Simply you don't find, simply you calculate the difference between the original and the desired. You calculate the difference between the probability distributions of the system. That is a concept behind the Boltzmann. And then some important points. Recurrent structure it used, stochastic neuron, that is 2 states, either 1 or 0. And we have 2 states. The one more, another important point is, here I have 2 states. One is a free state, another one is a frozen state. Free state means the neurons can go anywhere. Okay. Frozen state means at a particular state only it remains. Okay. And here also the weight are associated with 2 neurons, have a synaptic connection between either presynaptic or postsynaptic. So due to time constraint, I'm going fast, sorry. Then that's a probabilistic one. Energy function also we are using. We have the pseudo temperature. If you want to explain briefly this learning algorithm is, I have to say more about the half field network also. It is also another very big concept. Okay, so 2 modes. We have the clamped means fixed state. The neuron running means operate free from, it can take from any state. Okay, that's all about the learning rule. Just for time constraint, I cut short the learning algorithm, and then we go for the applications. It's a very important one. First one is a handwritten character, that is see the input. So my neural network will give the exact output. Okay, here I'm giving the 4 like that. It may be trying to recognize the handwritten character, any form. It may be letter or digit. And then the next one is speech recognition. I can convert speech into text and text into speech also. That is also another application behind the ANN. And the earlier model based on the statistical models only, like hidden Markov model. But after the advent of deep learning, various type of neural network will give the accurate classification. Then signature classification, it will identify whether my signature is a authentic one, is mine or some fake. The signature is a fake or not. Okay, you can easily identify with the help of the neural network, and then you can identify the face also, face recognition. Okay, based on the identity of the person, we can use a neural network. It's the most popular type, conventional neural network. Here we are using the for face recognition. I already told that for images you can go for CNN. It's the most popular type of ANN, face recognition. Then some of the merits, advantages. So we can easily store in the data. It does not employ the database. Instead, it store all the data on the entire network. No need of database. Okay. Even some of the data, some data disappear from one location temporarily. Some data will be lost. No need to worry about it. Then we have the multifunctional concept also. Multiple tasks we can do. Fault tolerance. Fault tolerance means suppose if we remove one or more ANN cells, it does not affect or does not prevent the entire network from the output. Okay, that is called the fault tolerance. Even you can work with incomplete or less knowledge also. Then the drawback or it depends on entirely depends on the hardware. That is the problem behind the ANN. To overcome the problem only we go for a CNN. Okay, there is no proper structure. Construction of artificial neural network. There is no proper structure. There is no time limit also. Then again, another drawback is difficulty in solving non-numerical problems also. Okay, that's another difficulty one, and the behavior is unrecognized. These are some of the drawbacks behind the artificial neural network. And the future scope, we can wide range of applications. We can use artificial neural network in healthcare, finance, retail, manufacturing. Everywhere, each and everywhere, we are using the concept. This ANN will improve the accuracy and efficiency also. If you use in various domains like medical, financial, speech recognition, and its advancement in deep learning also. Due to the deep learning, it can process and analyze large number of complex data. ANN can use for image and speech recognition, NLP, natural language processing also. Real time, we can optimize for real time processing with quick decision making and self-driving cars and all we are using, or any fraud detection. That's the future scope for research scope. And then we can, that is improve personalization. That is a deeper the research to help to create more secure and customized experience for customer, like campaign, product recommendation, and the personalized healthcare plans. So integrating the ANN with other areas also, we can see the combination of different technologies like robotics. We can implement the ANN concept. Okay, so incorporate the concept of ANN with robotics, IoT, and better self-learning and making decision autonomously. So best wishes and happy research. So ANN are to play multiple significant roles in future technology, and their potential applications are vast and varied. Then it continue to evolve and become more sophisticated, become an even more critical component of many industries, and hence the researchers would find it challenging and interesting to foresee the possible diversifications and directions to deepen their explorations. Thank you. Thank you, friends. Thanks for your patient listening. I have taken some 10 to 15 minutes extra time. Sorry for that. Thank you.
Thank you.
Any queries? Shall I stop my presentation? Yeah. Any queries, friends?
Yes, ma'am. Good evening, ma'am. This is Felicia from SRM.
Yes, ma'am.
Ma'am, actually, you said about IoT. Also, we can use this ANN algorithm. And
Yes.
may I know whether we can use it for sensor data?
Yeah, sensor data means in IoT. So actually, sensor means either you can go for the Raspberry or the architecture is different. But anyhow, in IoT, that architecture and some model framework and all, we can we can use this neural network also. Each and everyone is somewhat binded one only. Already day before Sadish had told, no, if it is a image processing or virtual reality, whatever it is, everyone is interconnected only. So you have to refer the papers which involve the neural network based on IoT, neural network related with IoT. Just we refer the paper. Okay, we can combine any kind of that is any topics mixed with neural network and IoT or neural network with robotics. You just search the papers. Definitely, you will get a paper related with IoT and neural network. Okay.
Okay, thank you.
Thank you, ma'am. Any other questions, participants? The basic concepts only I explained.
Participants, you can unmute and you can ask your questions if you have any
Yes.
queries. Kindly unmute and ask.
Any questions in chat box?
Clearly explained only this.
Okay, thank you. Yeah, if you have any queries, you can contact me through mail or my phone number. Anytime I'm ready to answer. If I know or I refer some other things and then I can tell you the answer. That's all.
Ma'am, shall we proceed, ma'am?
Yeah,
Because audience have no questions.
questions. Yeah, go for vote of thanks.
Yes, ma'am.
We will conclude.
Now I request Ms. B. Radhika, Assistant Professor, Department of Computer Science, to propose vote of thanks.
Thank you, ma'am. No duty is more urgent than that of returning.
Yeah, audio not able to hear. Sudha?
Sorry, ma'am. Now.
Yeah, audio.
Yes, ma'am.
Yes.
Yeah.
No duty is more urgent than that of returning thanks. Good day to all present here. I deem it a great honor and privilege to propose the vote of thanks for today's session. First and foremost, I thank our today's resource person of the day, Dr. R. Thirumalai Chelvi ma'am, Associate Professor, PG and Research Department of Computer Science, Government Arts College, Men, Nandana. Ma'am, today the session was very interesting. You explained about the basic concepts of ANN, how does ANN work, and what are the types of ANN, and how the ANN will works. And you also explained the different types of learning, like error correcting learning, competitive learning, etc. And you also explained the future research scope for ANN. Ma'am, really, the topic was very useful for the budding research scholars, ma'am. And my special thanks to resource person, ma'am, for arranging the resource person for our FDP. I extend my sincere thanks to our honorary correspondent, principal and vice principals, faculty members for making this session a resounding success. Totally, 255 faculty members registered for the FDP and 130 plus participants have participated. Special thanks to all our participants from various colleges and university. Once again, thank you all for making this FDP memorable one. Thank you, ma'am.
Thank you. Thank you, Sudha.
Thank you,
Once
Radhika.
again,
Thank you, ma'am.
thanks
Yes,
to
ma'am.
Sudha and the team members for their full
ma'am.
effort for the past 20 days or 1 month. No, you have before 1
With
month.
your
you have
guidance,
planned.
yes, ma'am. Yes, ma'am.
Thank you. It's my pleasure, ma. It's my pleasure.
Thank you.
Thank you so much.
Thank
I'm
you,
ready
ma'am.
to- Sure. Participants, if you have any doubt, if any clarification, any papers, anything, you just contact me through mail or get my phone number from the organizers. At any time, I'm ready to help you. Thank you. Thanks for your patient listening. Thank you. Shall I leave?
Thank you, ma'am. Thank you very much.
Yeah, fine.
Yes, ma'am.